Alright, so today we're going to prove that triangles are similar. So far when we're trying to go through and prove that two figures are similar, we have to show that all the corresponding angles are congruent and that all the corresponding sides need to be proportional, right? Well, doing that over and over and over gets to be a pain. So are there some shortcuts? Yes, there are. The first one is angle-angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Now, the reason we only need two angles is because we know that these angles, L and Z, will be congruent by the third angle theorem. Remember, we learned about that last semester. So, all we need for this guy is two congruent angles. Now for side-side-side similarity, it's kind of like side-side-side congruence, except instead of having all the sides congruent, I need three pairs of corresponding sides to be proportional. So here's how that would look. I would go ahead and make sure that AB over its corresponding side PQ, that ratio is the same as BC over its corresponding side QR, and make sure that's the same as AC over its corresponding side PR. Make sure all those ratios are the same to make sure that they're proportional. Oopsies, all sides. Alright, and then we have side angle side similarity. So kind of like side angle side congruence, we want two sides that are proportional, two sets of sides that are proportional to each other, and then with this angle in between. So I would want to make sure that corresponding sides XY, oopsies, over MN, that ratio is the same as these two corresponding sides XZ over MP. So we would want to make sure that those two ratios are the same. So we would want two proportional sides with angle between. Alright, so now we're going to go through and decide, are these triangles similar or not? So, on this first one, all they gave us were some angles. So first of all, we know that this angle right here and this angle right here are congruent to each other since they're both 90 degrees. So what we're going to have to do is find out what's this other angle right here. So all my angles in a triangle add up to 180. So I'm going to go ahead and take 90 plus 60 plus x equals 180. 90 plus 60 is 150. 180 minus 150 gives me 30 for this angle. So those two angles are not congruent. So since I don't have congruent angles, that means that they are not similar. So I'm just going to circle no. I don't have to do a similarity statement if they're not similar. Alright, over here. So far, we at least know that angle B is congruent to angle E. We have to find out, are any of our other angles congruent? So it doesn't matter which triangle you want to use. I'm going to use triangle ABC. All of my angles add up to 180 in a triangle. So I have 48 plus 77 plus angle C equals 180. Let me move this over. So then I'll take 180 and subtract 48 and 77 from it. We'll end up with 55. So now I know angle C is 55 degrees. So now I know angle C is congruent to angle F. We can also go through and do the math, but we do know that because I have two angles in one triangle congruent to two angles in another triangle, then that means that angle D and angle A are also congruent to each other. So, are they similar to each other? Yes, because I have two angles congruent to each other, so it's angle-angle similarity. Remember that little squiggle means similar. So the similarity statement just says triangle this is similar to triangle this. We used to do it all the time with congruent statements. So what we'll do is we'll start with triangle A, B, C is similar to triangle. And then this is where we have to be careful. What does A match up with in the other triangle? D, so D has to come first. What does B match up with in the other triangle? E, so E has to come second. What does C match up with in the other triangle? F, so F has to come last. All right. So looking at this next guy, we want to decide, are these two triangles similar? Well, remember, those lines right there means, or the arrows on those lines mean that they are parallel. So that will matter in a minute. Likely right now, I bet you're telling me that they have vertical angles congruent. And you are right. I hope you still see those whenever we have a bow tie. Other angles that we have when we have parallel lines in a transversal are alternate interior angles. So angle W and angle V will be congruent because of alternate interior angles. Remember, we learned about that Unit 4 last semester. So are these two triangles similar? Well, yeah, we got two sets of angles congruent. So angle-angle similarity. And then we'll start with triangle. Let's just go with WXY. Similar to triangle. Let's see, W matches up with V. X matches up with Z. And Y matches up with Y. All right, let's look at these next ones. So, right now, we've got a bow tie. So we've got vertical angles. Now we have to compare the sides. Now let me give you some advice on comparing the sides. Let's look at EUF, this triangle over here. The shortest side of this triangle is 8. So I'm going to start with 8. Over. And it should correspond to the shortest side in the other triangle, WUV. Shortest side over here is 16. So I'm going to put 8 over 16. And then I'm going to compare that ratio to the longest side over here is 9. And the longest side in the other triangle is 18. So don't necessarily go by where they are. Go by match up like shortest to shortest, middlest to middlest, longest to longest. So if we go through and simplify those, 8 goes into both 8 and 16. So I get 1/2. 9 goes into both 9 and 18. When I simplify, I get 1/2. So, are they similar? Yes. I have two sets of sides proportional and the angle in between them. So, two sets of sides with the angle in between, side angle side, similarity. similarity statement. All right, let's start with triangle. EUF, similar to triangle. All right, E matches up with V, U matches up with U, and F matches up with W. Also, just so you know, right here, with that simplified to B, that is your scale factor. All right, let's knock out a couple more. All right, all we have are sides over here, right? So remember my tip, go with the shortest side to shortest side. So the shortest side in EFG is 40. That will go over the shortest side, 112. Let's see if that's the same as the middle guy is 50. And the middle guy over there is 40. All right. Then my longest side, and that one is 55. Over my other longest side is 154. All right. Now, go ahead and take one of my calculators and click on that N over D button. And I want you to put each of these fractions in. Or just divide each of those numbers on your regular phone calculator. Take 40 divided by 112. Take 50 divided by 140. Take 55 divided by 154. Are all of those the same? So when you put those into your calculator, you're going to get 5/14 over 5/14 equals 5/14. So, since all those ratios are the same, yes, they are similar because all the sides are proportional. So that's side, side, side similarity. All right, now E, G matched up with R. Oopsies. There's 40 and 112, 50 and 40, 55 and 154. Okay, so let's start with triangle EFG. It's similar to triangle. All right, so E is between the straight and the super squiggly, and so is Q. So E matches up with Q. F is between kind of squiggly and super squiggly, so that matches up with R and the other one. And then there's G, so G has to match up with F. All right, let's look at these next two. So we know that at least angle Z and angle V are congruent. Are there any other angles that we know are congruent? Well, actually, they both have this angle W in common, right? So angle W will also be congruent to itself. Remember, that's the reflexive property. It doesn't matter. I'm just excited to remind you. So, since I have W congruent to itself and angle V congruent to angle Z, yeah, these guys are similar because I have two sets of angles congruent. So, angle-angle similarity. So, let's start with triangle WVX is similar to triangle. W matches up with W, V matches up with Z, and X matches up with Y. All right. We're going to use use this picture over here to complete the following. So triangle PQR. I would love for you to pause me and go ahead and fill this out yourself, because I know you can do it after the ones that we just did. Okay, so triangle PQR is similar to triangle. P matches up with L. Q matches up with M. R matches up with N. So triangle LMN. Oh, you stop. I feel it. Alright, so they're going to tell me that LM, this part right here, over PQ, this part right here, is equal to something over QR. So, over in the other triangle, what matches up with QR? MN over here. So I'm going to need MN up here on top. Notice LM and PQ are corresponding, so they go on top of each other. MN and QR are corresponding, so they go on top of each other. LM and MN are from the same triangle, so they're across from each other. PQ and QR are from the same triangle, so they're from across from each other. You just go same Z's with same Z's. It's the best thing to try to do. Now, with this model, we're going to go down here. We know that LM is 12. PQ is Y. We knew that MN was 15 and QR is 20. So then when we're trying to solve for Y over here, I'm just going to cross multiply. I'm going to take Y times 15 and get 15Y. And I'm going to take 12 times 20 and get 240. And then I'm going to take 240 and divide it by 15 to get Y, and Y will equal 16. 16 right there. And then we want to find the scale factor. So any two corresponding sides with numbers are going to be my scale factor. So I had 15 over 20. If you leave it like that, I'll take it, but I'd love for you to simplify it. The biggest thing that goes into both 15 and 20 is 5. So I'll divide by 5 and get 3 over 4. So my scale factor is 3/4. All right. Now we want to decide which of these sets of triangles are similar. So let's start to compare the sides. So let's start with triangle ABC and triangle DEF. All right, so let's start putting sides over each other. So let's see, an ABC, AB is 5. That matches up with DE, and that's 4. See, BC is 8, and that matches up with DF, which is 7. And then BC is 7, which matches up with EF, which is 6. Now, all of these fractions are all simplified. That's as simple as they can go. None of these fractions are equal to each other. So these are not proportional. So that means that they are not similar. So we tried A, B, C, and D, E, F. Now let's try maybe triangle DEF and triangle GHI. So with DEF, we got DE, which is 4, and that matches up with GH, which is 2. We've got EF, which is 6, which matches up with HI, which is 3. DEF, which is 7, that matches up with GI, which is 3.5. So I'll put those over each other. So then we'll go through and simplify that. 4 over 2 simplifies to be 2. 6 over 3 simplifies to be 2. 7 over 3.5 simplifies to be 2. So since all those ratios are the same, that means that triangle DEF and triangle GHI are the similar triangles. And this right here, what they all simplified to be, is their scale factor. Alright, in this next one, they need us to draw a picture. So, sketch the description, name the theorems that can be used to prove that the triangles are similar. If you're like, what theorems? Whoa. Here's what I'm asking. Am I going to use angle-angle similarity? Side-side-side similarity? Or side-angle-side similarity? That's what the theorems are that they're talking about. So, in triangle ABC, AC is 5, BC is 20, and angle C is 90 degrees. So I need a little right triangle right here. And then I'm going to use another one, so I'm going to copy you. Okay, cool. So here's what we got. Let's call you... So let's see, C is 90 degrees, AC is 5, BC is 20. All right, and then we have D, E, F. DF is 3, EF is 12, F is 90 degrees. So we want to decide, are they similar? So, the one that we would hope that we have right now is side angle side, since I only have 2 sets of sides and I have 1 angle in between. So the angle in between is already congruent. Now we just have to compare the sides. So let's compare the shortest sides. The shortest side from ABC is 5. The shortest side from DEF is 3. Man, I didn't draw that to scale. Oh. Equals. The longest side in ABC is 20. To the shortest side in DEF is 12. So 5 over 3, I can't simplify at all. So he's going to stay 5 over 3. 20 over 12, the biggest thing that goes into both of them is 4. So I'll divide those both by 4. And I'll end up with 5 over 3. So, since those ratios are the same, that means that my sides are proportional. So I have 2 sets of sides proportional with the angle in between congruent. So that's going to be side angle side similarity. Now, proportions are going to be super duper helpful to us. Remember, we match things up with samesies and samesies, so there's a whole bunch of different ways to set up these proportions. So, when we're going through and finding the value of our variable, here we go. So, I want to find the length of of MS. MS is right here. I'm going to put a little X there since that's what I'm looking for. I'm going to find out what MS matches up with in the other guy, and that's 12. So I'm going to start with 12 over X, or X over 12. It really doesn't matter. Equals, and then I'll have another fraction. Peanut, stop it. So something over here, we got 15 for DG. DG matches up with RS, which is 9 over here. So 15 and 12 are in the same figure, so they're going to go across from each other. 15 matches up with 9 in the other picture, and 9 is in the same picture with X. So 9 is going to go right there. So that way it has something in common in 15 and something in common with X. And then to solve, we'll cross multiply. So I'll take 15 times X and get 15X equals 12 times 9, and that's 108. Now just by looking at that, that's not going to come out pretty, so that's okay. I'll take 108 and divide by 15, and I'll get 7.2. And that's an okay decimal. He's not disgusting, that's fine. All right. The way the next one might get a little bit confusing is because, once again, we're talking about those alternate interior angles to be able to figure out what matches up. So alternate interior angles we learned about in Unit 4 last semester. It would be like angles right here and right here, or right here and right here. So we know those two sets of angles are congruent. So based on that, I'm going to go ahead and decorate my picture a little bit so I can see what matches up. I can see that 2 and 3 correspond, and that X and 5 correspond. And then, of course, Y corresponds with 7. So we're going to have to do 2 different equations here. 2 and 3 match up with each other. I'm going to go ahead and use those. I'm going to have 2. And I'm going to put that over 3, and I'm going to put a little equal sign. Let's go ahead and solve for X first. So X is in the same triangle with the 2, so X is going to go on top here with the 2. X matches up with 5 in the other triangle, so 5 is going to go underneath X and across from 3 since it's in the same triangle as 3. Then we'll cross multiply. 3 times X is 3X. 2 times 5 is 10. Then I'll divide by 3. I think it's easiest to just go ahead and put it over 3 and leave it as 10/3. If you really wanted to put it in your calculator and tell me that it was 3.3 repeating, I'd be fine with that too. Now let's go ahead and find Y. So I'm going to continue using 2/3 because remember we love our scale factor. So Y is in the same triangle as 2, so Y is going to go up here with 2. Y matches up with 7, so 7 is going to go down here underneath the Y, and 7 is in the same triangle as 3, so it's across from 3. Then we'll cross multiply again. 3 times Y is 3Y equals 2 times 7 is 14. Then I'll divide. If I were you, I would just leave it as 14 over 3. But if that hurts you, go ahead and pop it into your calculator, and it will tell you 4.6 repeating. So whenever you have 0.3 repeating or 0.6 repeating, that 0.3 repeating is just 1/3. 0.6 repeating is just 2/3. So those aren't gross decimals, those are pretty decimals. We like those. Alright, to determine the height of a very tall pine tree, you place a mirror on the ground and stand where you can see the top of the tree. How tall is the tree? By the way, you can actually do this. If we ever get bored, we could do that. Alright, so we're trying to find this length right here. So we want to set up a proportion. So let's make a proportion for you. So you are 6 feet tall, and you are 2 feet away from that mirror. Equals. Now let's look at those corresponding lengths in the tree. So the height of the tree, we don't know what the height of the tree is, so we're going to put an X across from the height of U. And then the tree is 24 feet away from the mirror. So the 24 is going to go down here with the 2, where you are 2 feet away from the mirror. And then we'll cross multiply. 2 times x is 2x. 2 times 24 is 144. So then I'll divide by 2 on both sides and get 72 feet for the height of that tree. All right, let's take a look at this last one. So you are standing 15 meters away from building A. So from here to here is 15 meters. And building A and building B are 35 meters apart. Okay, so this is 35 meters. Okay. If building A is 90 feet tall, so we got a 90 right here, how tall is building B? So we're going to have an X there. All right, so let's make a couple of different triangles. We have the triangle from U to the top of building A, and then we have a triangle from U to the top of building B. Now, looking at just building A, you are 15 meters away, and it is 90 meters tall, right? So I'm going to put 15 meters away over 90 meters tall, so the 90 will go on the bottom. Remember, you can set these up in a whole bunch of different ways as long as you match things up. Now let's take a look at this other triangle. Now I am not just 35 meters away, but 15 and 35 meters away. So that full distance is 50 meters. So my distance away is up on top. So my 50 is going to go up on there with my distance away. And then I have the height of the building that I'm trying to find over here, and that's x. Then we'll go ahead and cross multiply. 15 times x is 15x equals 90 times 50 is 4,500. Divide by 15 on both sides, so x will equal 300 meters. That's how tall building B is. All right, so turn the page and get started on your homework, or talk to Mr. Rampy and finish up your quiz from yesterday. I hope you guys have a good day. Bye-bye.